Welcome to Mars. Well, Stevenage anyway. This is the Mars Yard at Airbus Defence and Space. And this is Brian, a prototype for the next robot we hope to send to Mars, the ExoMars rover.
The ExoMars rover is due to launch in 2020 and is designed to drill beneath the surface of Mars to search directly for signs of life. But after last month's crash of the Schiaparelli lander on the surface of the red planet, will the rover ever make it into space? And where has this left the hunt for life on Mars? Welcome to The Sky at Night. Mars, our most Earth-like neighbour, has always fascinated us. Today, it is an apparently barren and lifeless world. Devoid of water, only a thin atmosphere covers its dusty surface.
But the geology of Mars suggests a warmer, wetter past, a time when conditions would have been much more Earth-like, a world that could have potentially been a home to life. So over the past 40 years, we've been sending missions to the Red Planet, looking for the signs of life. But so far, the search has yielded nothing but tantalising hints and disappointments. On tonight's programme, we'll be asking what last month's crash of the Schiaparelli lander means for future missions to the Red Planet. And Adam Rutherford joins us to ask a provocative question. Have we been deliberately looking in the wrong places for life on Mars?
But first, it's easy to forget that space travel can be hard, and nowhere is harder than Mars. Of the 55 missions we've sent there, nearly half have ended in failure. There's no greater demonstration of the challenges involved than the recent ExoMars mission to the Red Planet.
Launched in March this year, ExoMars spent 7 months travelling to Mars. But the most difficult part of the mission would come as it approached the Red Planet. On the 16th of October, the ExoMars mission arrived in orbit about Mars and broke out into its two constituent parts. The Trace Gas Orbiter went into orbit about the planet, while the Schiaparelli lander descended to the surface. The two parts of this mission had very different goals. The Trace Gas Orbiter's purpose is scientific, designed to study the Martian atmosphere from orbit, while the Schiaparelli lander was designed to test a new landing system, which, if successful, would be used to deliver a rover to the surface in 5 years' time. So it was crucial that the test was a success. And on October the 19th, the teams in Mission Control looked on nervously as Schiaparelli made its final descent to the surface. Initially, it all seemed to be going to plan. Schiaparelli entered the atmosphere at 21,000 kilometers per hour, its heat shield protecting it from the intense friction with the Martian atmosphere. The plan was it would use a 12-metre wide parachute to slow down. Then, as the parachute detached, its retro rockets would fire for 30 seconds, slowing its descent so it would land on the surface at walking pace. But in Mission Control, expectations soon turned to concern as contact with the lander was lost. What we now know from telemetry received from the lander was that the parachute was jettisoned 30 seconds early. The retro rockets, which were also meant to fire for 30 seconds, only fired for 3. As a result, the lander was plummeting towards the surface from about 2 kilometers up and hit the ground at great speed. And now we have photographic evidence of what happened. This picture of Schiaparelli's landing site was taken by NASA's Mars Reconnaissance Orbiter in May this year. And this one shows the same location the day after Schiaparelli disappeared. You can clearly see new features in the second image. We think that this bright spot here is the parachute. And then a kilometre further north, we have this dark patch. We think that's the lander itself. Now, on this scale, it measures 40 by 15 metres. What we think happened is that the unused fuel from the retro rockets exploded, blowing up Schiaparelli and sending debris over a wide area. In this next image, you can see a lot more detail. Here, you can see the explosion, but it's asymmetric, longer in one direction than the other, and it left a crater 0.5 metre deep and 2.4 metres wide. There's also this trail coming off, which is probably a piece of debris that rolled away. That's what happened. But why did Schiaparelli crash? Chris has been talking to ESA spacecraft operations manager, Andrea Accomazzo, about the latest theories.
Well, Andrea, thank you for talking to us. What do we know about what happened to Schiaparelli?
Well, we know a lot of things about Schiaparelli. We are fortunately in the position to record all the telemetry data that Schiaparelli transmitted during the descent toward the surface of Mars. What we noticed as well, that Schiaparelli released or abandoned, if you want, the parachute earlier. This was triggered by a very high shaking, if you want, of the probe when the parachute was inflated. And these very strong movements caused, if you want, the software to propagate wrong information. And that's why Schiaparelli, after a few seconds, believed it was much closer to the surface than it was.
Why is the sequence not pre-programmed? It seems like you might know at what stage the craft will be at what height above the surface. So it feels from the outside like you could have just had these things go automatically.
There are some events that you can do in this way. For example, the moment we separate the front shield, the heat shield, from the probe is timed 40 seconds after the inflation of the parachute. But not everything. Some of them are really depending on the conditions we observe. And you have also a daily local variability of the atmosphere. It's exactly like the weather here on the Earth. So that's why we cannot program everything on board the probe just by time. We have to react to the local condition, which the probe measures through its sensors.
And so this was a test of the landing system. It's some parts of which will be used on the 2020 mission. I have to ask you about the political fallout. We're still waiting for confirmation that the politicians will fund the 2020 mission. There's a few hundred extra million euros to find. Are you worried that they'll look at Schiaparelli and decide that this is too difficult or that this is too hard?
Well, of course, we are worried. In the end, we fully understand that first, there is money missing to complete the intended program. The partial success or the failure, partial failure of Schiaparelli, everybody is free to see it as he wants, might induce concerns or doubts about what we are doing. I am not directly exposed to this level, but from my point of view, I take care of the technical part of flight operation. I would say we have demonstrated that we are capable, very capable, I would say, to navigate a probe towards Mars, and navigate it accurately enough to land exactly where we want to land. But I'm confident, to be honest.
Andrea, thank you very much. Thanks for talking to us about Schiaparelli.
Yeah, thanks to you. Bye.
The decision on whether the ExoMars rover will receive the funding that it needs will be made by the ESA member states in December, and it will be a nervous wait. But while Schiaparelli was crashing onto the surface, the other half of the mission, the Trace Gas Orbiter, was successfully slowing itself into orbit around Mars. Its mission is to investigate one of the great modern mysteries of Mars. In 2003, plumes of the gas methane were first observed coming from the surface of the planet, and ever since, scientists have been trying to explain how it got there. Now it's hoped that TGO, the Trace Gas Orbiter, will reveal the secrets of this Martian methane. To find out more, Maggie went to the Open University to meet Manish Patel.
So why is methane so interesting?
It shouldn't be there, to be honest. Methane is quite common in the solar system, but much, much further out. Inside, in the inner planets of the solar system, where it's warmer, the methane should have been destroyed a long time ago. Methane is destroyed by sunlight. So the fact that we're seeing it on Mars is very, very interesting to us. It means that something is going on to create it now at this time. So there's an active process going on there making this stuff. So the question is, why is it there?
So what are the options for making methane on Mars?
There are always multiple options, obviously. There's never an easy answer. So, but in its broadest sense, there are two options: biological or abiological. There are geophysical processes that can also result in the production of methane.
It could be geological, it could be from life. Can we tell the difference?
That's the hard bit. So we'll measure the isotopes of methane. That will begin to give us a clue into whether or not life created the methane. Life tends to prefer lighter isotopes of methane. So that's what we know from Earth. We don't know if the same applies on Mars, so it's not an unambiguous answer, that's for sure, but it's a clue. We can also take images with the camera. For example, if we see a plume of methane appear, if there's an interesting geological feature that may have suddenly appeared in that particular area, then it's another clue.
So if it's biological, it means that there might be life on Mars?
Very much so. If you look at methane on the Earth, it's primarily, most of the methane in the Earth's atmosphere comes from life. So there's this very specific type of organism called methanogens. These organisms live in quite harsh environments that we would consider harsh. They don't like the presence of oxygen, and they take in carbon dioxide and hydrogen, and they produce methane as a byproduct. So methanogens have, of course, been suggested as a potential extremophile, so an organism that likes extreme environments to be a potential organism that could be either active today or in the past in the subsurface of Mars.
When will we start getting data?
So the orbiter is currently in orbit around Mars. It's not in its final orbit yet. It's in quite a large elliptical orbit at the moment. So we have to go from this huge orbit down to a nice circular one. We're doing it slowly. It'll take probably into late 2017 before we start, but we're hoping around this time next year we can start our primary science phase.
Well, I'm looking forward to meeting up again next year and getting the latest results.
For sure.
Thanks very much. It's been fascinating.
The search for alien life has been going on for hundreds of years. Whether it exists or not is one of the great scientific questions. And yet there's a suggestion that we've been deliberately avoiding the most likely places to find life on Mars. We sent Adam Rutherford to investigate.
I'm a geneticist. I'm interested in the origin and the evolution of life. How does life just spring up? Is it rare, or is it inevitable when the conditions are just right? Now, these are tricky questions to ask because here on Earth, we don't really have anything to compare it to. But it's exactly these questions we're hoping to answer by looking for life on Mars. If we did find evidence for life on Mars, either living or extinct, and it had chemistry which was different from our own, then that would suggest that life has emerged on more than one occasion in our solar system. If it was similar to what we find on Earth, then that suggests that somehow it had been transported between the two planets, and that is equally exciting. And if it's not there at all, maybe we're just rare, and that makes us even more precious. Whatever the answer, it makes the search for life on Mars one of the most important goals of space exploration. One of the most important goals of all exploration. But Mars is a big planet. Where should we be looking? Mars is a pretty inhospitable place, but there are a few locations where we think the conditions to support life might exist today. And it's the blind optimist in me that thinks that these are the spots where we should look first. The first thing that life needs is water, and we know that there is plenty of it on Mars. It's mostly locked up as ice beneath the surface. Now, this is a photo taken by the Phoenix lander in 2008, and it shows that you just have to scrape just beneath the surface to reveal ice. In fact, we now think that there is ice not too far beneath the surface in the high latitudes of both the northern and the southern hemisphere. On Earth, we know that life can survive frozen in ice for thousands of years, so this may be one place to start looking. Elsewhere, and this is one of the most exciting discoveries of recent years, this is a photo taken by the Mars Reconnaissance Orbiter in 2015, and these streaks we see here, they've got a very catchy name, recurring slope lineae, is evidence, we think, of water appearing and flowing through the surface. Now, we think they're seasonal as well. They're there in the Martian summer, but they disappear in the winter. It's still minus 25 degrees Celsius in the summer, which means that we think that this can't be pure water. It's going to be strongly brine, so very salty, because that has a much lower melting temperature. We know that there are a handful of organisms that have adapted to survive in these conditions here on Earth. So why not on Mars? And then there are other areas where life might survive. We know that recent impact craters can retain huge amounts of heat, enough to power hydrothermal activity for thousands or millions of years. And there are caves that may provide protected local conditions, shielded from the intense radiation on the Martian surface. Now, these are known as special regions. And if I was going to look for life on Mars, these are the places where I would go. But you know what? We have never sent a life-detecting mission to any one of them, nor are we likely to soon. And the reason is an international agreement known as planetary protection, kind of like an exclusion zone that quarantines the special regions and prevents us from going there. The reason that the special regions are out of bounds is that it's feared that any spacecraft we send to them could carry extremophiles from Earth that could potentially survive there. It seems like a pretty small risk to me, so I went to see Professor Mark Sefton, a geochemist at Imperial College London and a member of ESA's Planetary Protection Working Group. Okay, Mark, what's going on here? The most interesting places that we keep finding on Mars, we're specifically not allowed to go to them.
Well, you never contaminate a crime scene. You've got to make sure that you are almost certainly not sending a viable population of microorganisms to another planet. You only have to get it wrong once, and then the whole place is spoiled forever. And that's forever is quite a long time. Okay, so we send up loads of probes. What is the actual likelihood that we're going to take with them living things which are going to infect the environment on Mars?
Well, it's quite possible because microorganisms were becoming increasingly aware have incredible tolerance for very difficult environments. So it's entirely possible that you can load a spacecraft with microbes and send a viable population to another planet.
But is it, though? Do we have any idea whether it is possible that anything could survive that journey? If you run through the steps, if you say it's an extremophile from Earth that can only survive in extremely salty conditions, then it's got to be in a clean room at NASA, where it's not an extremely salty condition. Then it's got to be in space where it's exposed to extreme low temperatures and solar flares and all that hostility. Then it's on Mars, where it's in a 96% CO2 environment. And then it's got to make it to the, I mean, we're just adding up probabilities to the point where they've got to be minuscule.
Well, that's part of the thinking process behind planetary protection when we start to identify how many spores make a viable population. So that's sort of taken into consideration. And we use that. We use that to say this instrument or this spacecraft is clean enough to fly. I think it's entirely possible that some of these microbes can be transported to spacecraft preparing for launch. So I think transferring to the launch site is no problem. Transferring through space is a little bit more challenging, but we know that organisms can transfer between planetary bodies, and that's something that only has to happen once for it to be a loss of 4.6 billion years of information, because you've corrupted this very valuable extraterrestrial environment that could have told you something about the origin of life on other planets.
This is the most important scientific question possibly of all time. Is there life in the rest of the universe off Earth? You're ultra cautious, and you could probably tell that I'm a bit skeptical of this level of precaution. But as a scientist, you must, I mean, what do you feel about this? Do you feel you might be being too cautious?
Well, I'm constantly in turmoil because I think you should grab as much information as you can, as early as you can. But again, I feel the responsibility, so I have to be sensible. You take every opportunity, but also you try and protect your environment and discharge your responsibilities under the international treaties when it's all possible.
That was the most diplomatic answer I've ever heard.
I said I was going to be diplomatic.
So, that's the balance of the argument. Extreme caution to protect the pristine Martian environment versus our desire for the most important scientific discovery of all time. If it were up to me, I think the scientific benefits outweigh the contamination costs. Maybe none of this is going to matter in a few years' time. Last month, President Obama announced a human mission to Mars by the 2030s. Elon Musk wants to get there much sooner, with hundreds or maybe thousands of people forming permanent Martian colonies. Now, humans are messy. We leave trails of cells and DNA wherever we go. So when that happens, who's going to really care about a few bacteria?
We can put rovers like this on the surface of Mars and study it in minute detail. But how do we observe the planet from right here on Earth? This month, Pete is showing us all how we can observe Mars and how observations from here on Earth have affected the hunt for life on the red planet.
Our neighbouring planet Mars is easily visible to the naked eye. But it wasn't until the 17th century, when Galileo pointed his telescope at the sky, that it appeared as anything more than a bright point of light.
Well, there it is, the planet Mars shining away behind me. Rather beautiful to look at too. Now, during November, Mars is in the constellation of Capricornus, and that means it'll be visible in the south-southwest part of the sky at 6:30 p.m. before it sets at 9 p.m.
To locate Mars at the moment, use the summer triangle, formed from 3 bright stars visible in the southwest. Follow the point down for the same distance as the triangle is high, and Mars is the brightest object close to this location. Unfortunately, at the moment, even a powerful amateur telescope will only resolve Mars as a small smudge. But every 2.1 years, Mars reaches opposition, where it's at its closest to the Earth. This last occurred in May, when Mars was just 46.8 million miles away. It was during one of these periods in 1877 that Giovanni Schiaparelli, after whom the lander was named, used an 8.6-inch refracting telescope to map Mars in detail.
The light regions he called continents and the dark regions he called seas. But he also noticed something unusual crossing the surface of Mars, because there were some dark lines which he called canali. Now that means channel in Italian, but the English misinterpreted this and they thought it meant canals. Now those would be artificial structures, of course, and that would mean there would have to be intelligent life.
2 decades later, Percival Lowell decided that the canals were indeed artificial structures, built to transport water from the caps to the equator. He proceeded to map hundreds of them.
But the problem with the canals was they didn't actually exist. And the crisscross network of dark lines that Schiaparelli and Lowell saw crossing the surface of Mars were merely the result of the human tendency to see patterns in everything.
Modern images captured at opposition show spectacular global detail, providing a continuous record of Mars's seasonal changes and global dust storms.
The next really good opposition of Mars visible from the northern hemisphere won't be until 2020, and that will hopefully coincide with the launch of the ExoMars rover and also NASA's Mars 2020 missions. So that should be a really exciting year for the red planet.
There's no doubt that the Schiaparelli crash is a major setback for the ExoMars programme, but preparations for the next phase are still going ahead, and here in Harwell, a team of British scientists are learning an essential skill: rover driving. This room is mission control for a team of space scientists and planetary geologists who are using a remotely controlled rover to explore a distant, barren landscape. I've come to meet team member Louisa Preston.
And welcome to our Mars Operations Centre.
It's got a ring to it, that, hasn't it?
It does, it does. So this is where the Murphy mission, which stands for the Mars-Utah Rover Field Investigation Mission, is housed. This is where all our British scientists are working together to try and emulate a Mars mission.
And so to do that, you've got a real rover exploring a real landscape.
Yep, this landscape.
But not Mars.
No, not Mars. This is actually the Badlands of Utah. It's around 7 kilometres outside of Hanksville. And yeah, we don't actually know where the rover is right now. It has been dropped.
Landed.
Landed, yes, in a landing ellipse, just like we'd have on Mars. But the idea is it gets dropped, it opens its eyes, which is the camera eyes, and we get sent images. And from those images, we need to localise ourselves, find out where the rover is, what it's looking at, and start doing some exploring.
The purpose of this mission is to allow the team to build the skills needed to remotely explore a distant world, so that when a European rover does go to Mars, they'll be ready and prepared. And so for a geologist, how different is exploring a landscape with a rover compared to being there and being able to look around and touch things?
It's incredibly difficult. The main point of this mission is actually really to train us to almost be quite hands-off, to make us look at images and choose things, choose sites of interest that might be able to answer our overriding science question, which is to hunt for signs of life, just like the ExoMars rover will do in 2020.
So what will ExoMars be able to do that Curiosity and the other rovers haven't done so far?
So the key thing ExoMars is going to be able to do is drill up to maybe 2 meters into the surface. And so that's something we're also going to emulate in Utah. And the reason is the surface of Mars is cold. It's bombarded by UV radiation. If we're going to look for biosignatures of life, the chances are they are buried and preserved underneath the ground using the rocks for protection. So drilling is the best way to get to them. We are trying to find the type of rocks that we know might be able to preserve ancient signs of life, so such as clays and sulfates, which is what we also have on Mars. So hopefully we can find some clays and sulfates, we can analyse them using the tools on Murphy, potentially find evidence of organisms. Then we can prove that we know what we're doing, we can prove the tools know what they're doing, and then hopefully when ExoMars 2020 comes along, we know exactly where to go and what to look for.
And you've got a like-for-like comparison in some sense as well. Well, let's hope there's life in Utah. Good luck.
Absolutely, thank you very much.
We'll talk to you when you get back from Mars. Watching a team practice exploring Mars is incredibly exciting, and it looks like good fun too. Of course, after Schiaparelli's untimely demise, we have to wait to see if the politicians will let ExoMars fly. But we've got TGO safely in orbit around Mars, and so it's still an exciting time at the Red Planet.
That's it for this programme, but do check out the Star Guide on the website. We'll be back next month with an update of the biggest stories of the year. In the meantime, get outside and get looking up. Good night.
As film director Ken Loach's work continues to inspire debate, a chance to see the groundbreaking 1966 drama that shocked the nation. Kathy, Come Home, next on BBC4.